Okay, hi guys. So in this lecture, we'll be starting on with redetermining step. So let me put down the heading first. We will be talking about redetermining step. In short form, it is also called as RDS. So this is nothing but the slowest step in a complex reaction. Slowest step in a complex reaction is called redetermining step. And rate of reaction is controlled by RDS. Rate of reaction is controlled by RDS. Next, the order of determining step may or may not be equal to the order of reaction. Order of reaction may or may not be equal to order of redetermining step or RDS. But in general, it is observed that order of RDS is in fact equal to order of reaction. But this is just the general principle. This is not universal. And another point is that all zero and fractional order reactions are complex reactions. This is nowhere related to RDS, but this is a general point which I'm just writing here. So let me put down a note here that all zero and fractional order reactions are complex reactions. Next, let us see the relation between rate constants. So for an elementary reaction, we have, let's suppose 2A gives B. So the molecularity of this reaction would be equals to 2, and the order of this reaction would also be equals to 2. And rate of reaction or small r would be equals to Kr times A square, or concentration of A square. And what would be the rate of dissociation of A? So rate of dissociation of A would be minus dA by dt, which is minus d concentration of A by dt, which would be equals to, let's say, kd times A into to the power 2. And rate of appearance of B would be plus d B by dt, which can be written as Ka times A square. Now we know that rate of reaction is equals to reaction, or small r is equals to rate of dissociation of A, which rate of dissociation of A would be this divided by stoichiometric coefficient of A. Stoichiometric coefficient of A is 2 in this case, hence it would be half minus of dA by dt. Similarly, we can write which would be equals to rate of appearance of B divided by the stoichiometric coefficient. Stoichiometric coefficient of B is 1, so it would be simply dB by dt. So from this we can write that kr times a square would be equals to minus half dA by dt, and this would be equals to dB by dt. So now as we know that dA by dt minus would be equals to k of t a square, and we know that dB by dt is equals to k of appearance times a square. Okay, so we can write that from here we can write that kr times a square would be equals to half of kd times a square, which in turn would be equals to ka again a square. Now from here we can write that kd is equals to twice kr. Kd is the rate constant for dissociation of A, and similarly we can write that Ka, or the rate constant for appearance of B, would be equals to rate constant. So with this we come to the end of this lecture. In the next lecture we will be seeing the relationship of rate constants for a second order complex reaction. So till then, good luck and goodbye.